My name is Paul, and I'm going to talk about a question from the end of the sprint test last year. Here it is. Among all 10 factorial permutations of the set of numbers from 1 to 10, how many have the property that a sub 1 plus a sub 2 plus a sub 3 plus all the way to a sub k, the kth partial sum, is not a multiple of 3 for any choice of k? The first thing we can do is sanity check. A sub 1 plus a sub 2 plus a sub 3 all the way to a sub 10 is going to be 1 plus 2 plus 3 all the way to 10. That's going to be 55, and that's not a multiple of 3. We can't start by saying, oh, one of the numbers is definitely a multiple of 3, and there are no permutations that work. And there's actually a permutation that works. If we move 2 all the way to the end and then look at the partial sums, we get a bunch of numbers, and none of them are multiples of 3, so that means the answer should be non-zero. So next, we only care about what a number is modulo 3. So we can partition the numbers as follows. 1, 4, 7, 10, all plus 1 mod 3, 3, 6, 9, all 0 mod 3, 2, 5, 8, all negative 1 mod 3. And the 0 terms, they don't actually matter, except that they can't be at the start, because if we have a partial sum and then we add 0, well, it's still a multiple of 3 or not. It doesn't change it. All we know is that a sub 1 can't be a multiple of 3. So now we're going to move all 3, 6, and 9 all the way to the end, and then worry about placing them later. The first number, a sub 1, is going to be either negative 1 or plus 1 modulo 3. So first we consider the case where it is negative 1 modulo 3. Since a sub 2 can't be 0 or 1, if it was 1, the next partial sum would be 0. It must be negative 1 mod 3 as well. Similarly, we know that a sub 3 is 1 mod 3, a sub 4 is negative 1 mod 3, and a sub 5 is 1 mod 3. Then we have a problem, since a sub 6 can't be 1, but it also can't be 0, and we already used all 3 of our negative 1s. So this means that a sub 1 should have been 1. And because at each step there was only one choice for the next value, we just flip everything to figure out what happens if a sub 1 is 1. And then we can do a bit more work. We know that a sub 6 is 1, and a sub 7 is negative 1, and all we have left to do is figure out what the answer is. Earlier, we could have put the multiples of 3 at the end, but they could have really gone anywhere but the beginning. So there were 9 choices for the position of 3, 8 choices for the position of 6, and 7 choices for the position of 9, because a sub 1 could not be one of them. To figure out which of the remaining a sub I are 1 mod 3 and which are negative 1 mod 3, well, we already know that information. It's almost alternating, right? So now we are ordering 1, 4, 7, 10 against each other and 2, 5, 8 against each other for 4 factorial and 3 factorial orderings. And this gives a final answer of 72,576.
Hi everybody, this is Tim. Hope you're enjoying our videos. If so, you know what to do: like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.